Alright guys, so for 5.3 we're going to chunk this in, it kind of has two parts to it. So the first part is polynomial functions, and this is where we've already done this. It's in function notation. Here they gave me w of x instead of f of x, but it means the same thing. When they say w of 5, just plug in 5 for that. So I have negative 2 times 5 cubed plus 3, since there's an x, put a 5 there, and then minus 12. Okay, you can simplify this from there. 5 cubed is 125. 3 times 5 is 15. And we just start combining all sorts of like terms here for a final answer of negative, try negative 247. Okay, they are going to make it a little fancier on us. I'm going to try this one over here. Here we're going to be plugging in the entire y squared plus 2. So anywhere you see an x, plug in y squared plus 2. Just like that. Now I notice with this piece here, when you have parentheses being squared, that's actually going to become y squared plus 2 being multiplied by y squared plus 2. So that became a FOIL problem. I'm going to go ahead and distribute on the last half since I'm here anyway. So now I have y to the 4th, 2y squared, 2y squared, and 4. Okay, all I did was the distributive property there. Now I'm going to go ahead and do a distributive property here. Actually, I'm going to combine like terms. That's 4y squared. Then I multiply that by negative 2. It's negative 8y squared. Let's see, what is that? Minus 8. Looks like I have some more like terms to combine for a final answer of negative 2y to the 4th minus 12y squared minus 16. Okay, like that. So then the next piece, I can tell you just by the exponents what a graph is going to look like. So check this out. If a function has a degree of 0, it's just a flat horizontal line. If it has a degree of 1, for example, I'm going to write you some example functions as we do this. So like this is y equals mx plus b, like maybe a 2x plus 1. The exponent on this x is 1. Okay, so it has a degree of 1. So it's a nice a nice slanted straight line. Degree 2, notice it's a quadratic, x squared plus x plus, a number there. This exponent. Okay, the number of the exponent is going to determine how many turnarounds we have. So notice, degree 3, this means it has an x cubed. This one's going to have an x to the 4th. This one's going to have an x to the 5th. You can kind of count the number of directions it goes is kind of how I think about it. So like this one goes one direction. This one goes 2 directions. So degree 2. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so if I just draw you a random squiggle line here, you should be able to tell me the degree. It is 1, 2, 3, 4, 5, 6, 7, 8. This one has a degree of 8. What is interesting about this is we're going to call this even and odd functions or polynomials. Let me scroll. Or actually, no, we're going to talk about end behavior first. End behavior is where the graph is going at the end of the graph, okay? So as this first one goes to the negative x direction, so as x goes negative, the function goes up, it goes to positive infinity. So now, as the function goes to the right and up, that means as x goes to positive infinity, the function goes to positive infinity. Okay? You're reading where the arrow is pointing. So this arrow here, I'm on the fourth one, it's going, as it goes to the negative x, the function goes up to a positive infinity. So as it goes right, positive infinity, it's going down to the negative infinity. You'll get to practice some of those. They're kind of interesting looking. So, another thing I want to talk about is even and odd polynomials. If your degree is even, the arrows will end up facing the same direction at the end. So this one is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 degree. Notice how that's pointing down at both ends. This one's a 4th degree. Okay, and it can go up. That's a 6 function. Arrows end up the same direction. Odds will be one going one way, the other going the other way, as far as your positive negatives. I think that's more or less... Oh, so what, as you try to interpret some of these graphs, you can determine the end behavior. So as x goes to negative infinity, it is going to... You're going to say as x goes to negative infinity, y goes to, since it's going up, I'm going to say positive infinity. Now on the positive side, I'm going to say as x goes to positive infinity, y goes to negative infinity. Determine whether it represents an odd degree or even degree. Well, since the arrows are catawampus and go in opposite directions, it means it's an odd degree function. So this one is odd. And, oh, one more fun thing we're going to do is talk about the number of real zeros. That's the number of times it crosses the x-axis. No imaginary numbers, x-axis. So since this one crosses 3 times, this one has 3 zeros. And here's a fun fact. If the leading coefficient is positive, that means that first segment will have a positive slope, versus if the first... What I mean by that is if it was like on this quadratic on this side here, y equals negative x squared plus 2x, you know, whatever. Notice, I'm sorry, I wrote that wrong. Let me try again. Notice that it's positive here, so this first segment has a positive slope. On 4a, let's pretend just for a moment maybe the equation is negative 2x cubed plus 1x squared minus 3x plus 5, making something up. Notice that this first part is negative, so that means this first part kind of has a negative slope. Remember, you always read slope as the graph travels from the left to the right. All right, that is it for today. Just so you know, tomorrow's is going to be in class, not a video lecture.